Good evening, everyone. So, welcome to my YouTube channel, Mr. Karan. Today, we are going to see sixth lecture on probability theory. In this lecture, we will study multiplicative rule or law, or you can say product rule or law. Okay. So, what is multiplicative? Multiplicative rule, you can say law, or you can say product rule or law. Okay. So, what is this? Let S be a sample space. Okay. And A comma B subset of S. It means A and B are events. Okay. Then we can probability of A intersection B is equal to probability of A into probability of B relative to. Okay. That is equal to probability of B into probability of A relative to B. Okay. This is called product rule. So we can prove this one also. Let's see its proof. Why this follow? Okay. So we know that P probability B. What is this? This is nothing but B intersection A upon P. Okay. So what is this? Now we can solve it. PA into P B relative to A. I can write B intersection is equal to A intersection B. Either you take B intersection A or A intersection B. Both are equal. So I can write A intersection B. So what I got? I got PA intersection B is equal to PA into B relative to A. Okay. Similarly, PA relative to B is equal to PA intersection B upon PB. Okay. So solving this, what we will get? Okay. So solving it, what we will get? This implies PA intersection B is equal to PB into PA relative to B. Let's say it equation number 2 and first one you take. So from 1 and 2, we get from 1 and 2 we get PA intersection B is equal to PA into P relative to B relative to is equal to PB into PA relative to B. So this is proved now. So corollary, you can say corollary, or you can say remark. Okay, you can say note. Now, if A and B are independent, then we know that P relative to A will be equal to PB, and PA relative to B will be equal to PA. So putting these values in this formula, so what we will get? We will get then, so therefore, putting these values in multiplicative rule, what we will get? PA intersection B is equal to PA into PB. Okay. For independent. Okay. Now, generalize multiplicative rule, one can say law or product rule slash law. What is this? What is this? So let S be a sample space and A1, A2, A3 and so on up to an minus 1 an are subset of S. It means A1, A2, an minus 1 an are events. Are events. Okay. Then probability of A1 intersection A2 intersection A3 intersection an minus 1 intersection an, okay, is equal to probability of A1 into probability of A2 relative A1 into probability of A3 relative to A2 intersection A1. Okay, like that product up to, then it will be P an minus 1 relative to A1 intersection A2 intersection A3 intersection up to an minus 1, and last one will be Pan in product A1. So this will be an minus 2 intersection A2 intersection A3 intersection up to an minus 1. Okay. Okay. So let's see its proof, how it follow. Okay. So we'll prove it by induction. For n is equal to 2, what is this? PA1 intersection A2 is equal to PA1 PA2 relative to A1. So the result is true for n is equal to 2. Okay. Suppose that result is true for n is equal to k. It means P A1 intersection A2 intersection A3 intersection AK is equal to PA1 PA2 relative to A1 up to so this is P A3 A2 intersection A1 multiplication P AK upon A1, A2 up to AK minus 1. Okay. Now we will prove that. Now we'll show that result also true for. Now check. Now what is P A1 intersection A2 intersection A3 intersection AK minus 1 intersection A3. Okay. Okay. So what I will do, I will consider this as a, so I can write A1, I can write AK here, I can write A1 intersection A2 intersection up to AK minus 1. I can combine this one intersection AK. Now this you consider this as a one event and consider this as a one. So this is my A and this is my AK. You apply the now probability, this multiplicative rule is valid for the n is equal to 2. We are considering this is a one event. This is also. So we have two events intersection. What is the probability? P A1 intersection A2 intersection up to AK minus 1. Probability AK relative to AK intersection A2 intersection up to AK minus 1. Okay. Let's take this equation number 3. Now we'll use this. Now put the value. So what is this? So we will prove that result is true for AK plus 1. So I will put here AK plus 1. Sorry. I should put here AK plus 1. Okay. So what is this? This is AK plus. So I can write AK. Okay. And I can write AK plus 1 here. So what this is AK. AK. Here I will write AK plus 1. AK plus 1. Okay. Now use equation number 3. Now put the value of equation number 3. What is the value of this one? PA1, PA2 relative A1, PA3 relative A2 intersection A1. Like that. So what is this? P AK relative to A1 intersection A2 intersection A3 intersection up to intersection AK minus 1. And last one is in product. This one, you write this one. P AK plus 1 A1 intersection A2 intersection A3 intersection A3. Okay. So it means result is true for NK plus 1. So this implies So this implies the result is or you can say formula. The result is true for n equal to k. Therefore, therefore, by mathematical induction method, method, the result is true for n greater. So this is true now. Formula is true. Okay. Now we will see some example on it. Now I would like to write one more here. So if A1, A2, A3, An minus 1, An are independent events, then PA2 relative to A1 is equal to PA2 and PA3 relative to A2 intersection A1, that is P3, PA3, okay, and so on. And so on. What is P, AK, P, AK minus 1 relative to A1 intersection A2 relative to AK minus 2 is equal to PAK minus 1 and PAK relative to A1 intersection A2 intersection up to AK minus 1 is equal to PAK. So this implies putting these values in generalized rule of multiplicative law. So then what we will get? We will get then this will imply therefore P A1 intersection A2 intersection A3 intersection A and is equal to PA1 PA2 PA3 in product PN. Okay. So this is important. If A1, A2, AN are relative, then probability of A1 intersection A2 up to AN is equal to product of probabilities of A1, A2, AN. Okay. Now we'll do some examples. Example 1. Okay. Suppose that we have a fuse box containing 24 fuses. Suppose we have a fuse box containing 20 fuses. Okay. Of which 5 are defective. Okay. If two fuses are selected at random and removed from the box in succession removed from the box in succession without replacing the first the first. What is the probability? The probability that both fuses are defective. Both fuses are defective. Okay. Solution. So we have a fuse box. Fuse box have 20 fuses. Okay. Out of which 5 are defective. So what is NS? Number of fuses in sample space. Sample space has 20 elements. Okay. Now let A is equal to the event of getting first fuse defective. So what is the probability of A? Or B will be the probability of that B will be the probability the event that B will be the event of getting second fuse defective. So once a fuse once A event is done, suppose first fuse is removed. So first fuse is done, then it is not replaced. Okay. So what is the probability of A? We have 5 fuses, defective fuses. So 5 upon 20. So this is 1 upon 4. Now after the event 1, so A event is done. It means first fuse is drawn, that is defective. Then it is not replaced. It is removed finally from the box. So what is the probability of B? What is this? So once A is done, we are taking B, probability of B relative to first event is done. Now 4 fuses are remaining defective and totally 19 are remaining. So this is the probability. Now we have to find A intersection B. Both the event A intersection B, the event that both the fuses are defective. Okay. Both the fuses are defective. So we have to find probability of A1 intersection A2. So how? By multiplicative rule / law of probability. We have PA intersection B is equal to PA into P B relative to A. So what is this? This is 1 upon 4 and this is 4 upon 19. So what is this? 1 upon 19. So this is 1 upon 19. It means PA intersection B is equal to 19. So this is the answer. Okay. Now we move to second example. So we will we will have more than 2 events. Then we will use generalized law of multiplicative rule. Okay. See second example. Example 2. Three cards three cards are drawn in succession without replacement from an ordinary deck of playing cards. Deck of playing cards. Okay. Playing cards. Find the probability that the event A1 intersection A2 intersection A3 occurs where A1 is the event that the first card is read as A2 is the event that the second card is 10 or a jack, and and third event is A3 is, and A3 is the event that the third card is greater than but greater than 3 but less than 7. So solution. So what we have? So we have to find this. We have to find the probability of A1 intersection A2 intersection A3. We need to find. So by generalized multiplicative rule or slash law of probability, we have what we have P A1 intersection A2 intersection A3. What is this? P A1 P A2 relative to A1 P A3 relative to A2 intersection A1. Now what is PA1? So first event is A1 is that first card is ace. There are first A1 event is getting a red ace. So how many ace are there? There are only 4 ace, and and we have among 4 ace we have only 2 red ace. So what is probability of A? Probability of A is equal to number of elements in A1. How many? Red ace is 2. Total number of cards in ordinary deck, okay, 52. So we have 2 upon 52. Okay. Now what is PA2 intersection PA2 relative A1? So first event is done. One card is drawn. Now there are only 51 cards. And A2 event is getting 10 or a jack. There are 4 jack. And how many 10s are there in jack? 4. So 8 options we have. Okay. So 8 upon 15. Now P A3 intersection A2 intersection A1. So what is this? This is A3 event is getting a card greater than 3 and less than 7. There are 4 types of cards. In each type of card, the cards among the cards which are greater than 3 less than 4. So we have greater than 3 and less than 7. 3 cards are there, 4, 5 and 6. And we have 4 types of cards. 3 into multiply by 4, we have 12 options. And because 2 cards already done, so upon 50. Okay. So put the base values. Putting base values we get. So putting base values we get P A1 intersection A2 intersection A3 is equal to, this was PA1, PA2 relative to A1, and this is finally A3 relative to A2. intersection. So what is this? We have calculated this is 2 upon 52. And what is this? This is 8 upon 51. And finally this is 12 upon 50. Solve this. Okay. Solve this. What we will get? So this you cut by, this is 13. Now this cut by 25. So this is will be cut 17 times. So we have 8 upon 13, 17 multiplication is 25. So what will be in denominator? Let's check it. 8, sorry, 13 multiply by 17 multiply by 25 is equal to 5525. 8 upon 5525. 5525. So this implies PA1 intersection A2 intersection A3 is equal to 8 upon 5525. So this is the answer. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you in next lecture.